Okay, let us look at problem number 4, 5 and 6 from chapter 5b of Hall and Knight higher algebra. Problem number 4 is we have to sum this series. So let us write S is equal to 1 plus half, no sorry, 1 plus 2 by 2 plus 3 by 2 square plus 4 by 2 cube, and we have to sum this up to n terms. So what will be the nth term? Nth term is going to be n divided by 2 to the power n minus 1, right? Now this is again an arithmetic co-geometric progression. You can apply the formula if you want to, but we will do it step by step so that this method becomes more and more clear to us. So 1 plus 2 plus 3 plus 4, you can see that the numerators are in arithmetic progression and each term is being divided by 2 square, so the common ratio is 1 by 2. So let us multiply 1 by 2 on both the sides, so this becomes 1 by 2s. Now this 1 becomes 1 by 2, so we will write it below 2 by 2. 2 by 2 becomes 2 by 2 square plus 3 by 2 cube plus, and this will be n minus 1 divided by 2 to the power n minus 1, and this last term will be n divided by 2 to the power n, right? Now we subtract s minus half s, so this is s minus half s is 1 by 2 s, and let us subtract the corresponding terms. So 1 minus 0 is 1 plus 2 by 2 minus 1 by 2 is 1 by 2 plus 3 by 2 square minus 2 by 2 square is 1 by 2 square plus 4 by 2 cube minus 3 by 2 cube is 1 by 2 cube, and so on. And you will see that this is again this is a geometric progression. So n minus 1 is 1 divided by 2 to the power n minus 1, and this will be negative n 2 to the power n. Now you can see that 1 plus 1 by 2 plus 1 by 2 square up till 1 divided by 2 to the power n minus 1, this is a geometric progression of n terms. Okay, so this means that we can write 1 by 2s is equal to, what is the sum of geometric progression of n terms? It is a times 1 minus r to the power n, but a is 1 here, so it is 1 minus half to the power n divided by divided by 1 minus half is half minus n divided by 2 to the power n. So therefore s is equal to let's write 1 by 2 s is equal to, let us simplify this first. So this is 2 times 1 minus 1 by 2 to the power n minus n divided by 2 to the power n. Therefore we can write this as 2 minus one by 2 to the power n minus 1 or just let us write it. Let us write it 2 divided by 2 to the power n minus n divided by 2 to the power n. So this means that 1 by 2s is equal to 2 minus n plus 2 divided by 2 to the power n, or s is equal to 2 times 2 is 4 minus n plus 2 divided by 2 to the power n minus 1. So this is our problem number 4. Now let us look at problem number 5. Again, you see that in problem number 5, it is an arithmetico-geometric progression which we have to sum till infinity, right? So we can apply the formula sum is equal to a divided by 1 minus r plus dr divided by 1 minus r square. Okay, and in this, what is our a over here? A is the first term, which is 1. What is r? R you can see is equal to 1 by 2, right? You can see that each of the successive term is divided by 2, 4, 8. So r is equal to 1 by 2 in problem number 5. And what is the common difference d? D is 1, 3, 5, 7. So this is d is equal to 2. Now if you plug these values, what you get is 1 divided by 1 minus half. So it is 1 divided by 1 minus half is half, plus d times r. So 2 times half is 1. 1 minus r is half, so it is half square, and you get this term is 2, this term is 4. So you get sum is equal to 6. So this implies that the sum of infinite number of terms of this sequence is 6. Now let us look at problem number 6. Okay, so for problem number 6, first we note that this is not exactly a arithmetico-geometric progression, because you can see that the coefficients are 1 plus 2, 3, but the next coefficient is 6. It is not 3 plus 2, 5, and similarly the next coefficient is 10. So it is 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, and so on. So we cannot apply this formula directly over here. So first we have to write our series as 1 plus 3x plus 6x square plus 10x cube and so on. Now we know that there is some common ratio x, because each term is getting multiplied by x. So let us multiply left hand side by x. So this becomes x, so we will write it below 3x. 3x becomes 3x square, 6x becomes 6x cube, and so on, right? Now if we subtract, we get 1 minus x times s is equal to 1 plus 2x plus 3x square plus 4x cube, and so on. Now this is an arithmetico-geometric progression, right? You can see that the first term is 1, second term is 2, third term is 3, 4, 5, and so on. And similarly the x term is 1, x, x square, x cube. So now we can use this formula s is equal to a divided by 1 minus r plus dr divided by 1 minus r square for summing up to infinity. So what we know is that this is going to be equal to a divided by 1 minus r, so it is 1 divided by 1 minus x plus d. d is 1 here, 1, 2, 3, 4, 5, so d is 1, 1 times x divided by 1 minus x square, right. So this is 1 divided by 1 minus x plus x divided by 1 minus x square. Now we can simplify this. This is simply 1 minus x plus x divided by 1 minus x square. So we get 1 divided by 1 minus x square. So what is sum s going to be? It is going to be 1 divided by 1 minus x cube, and we are done.